I've already talked in previous videos about WEP, or wired equivalent privacy, and said that that was pretty weak. We could break it in about 5 minutes, and that WPA was the stopgap. All we did was change the way the initialization vector works, and made a couple of other security changes that I talked about in that video in order to make it stronger. But finally, WPA2 came out about a year later. We had to make some changes in our computer infrastructure. Microsoft for one, had to add AES encryption to their system, and so that was added at I believe it was Windows XP Service Pack 3, and we also added something called CCMP. So let's talk about this WPA2 with CCMP and see what it looks like. Now we have a sender, and this sender has a pre-shared key that they chose. They typed it into the wireless router, and they typed it into their computer system. Now that is encrypted here, and then a number is added on to the front. A counter is added to the front, and that's sent across, and that is used then. Oops, I forgot to put the 1 there. There should be a 1 here, and that is used then to decrypt the message. Now that's fine for the first frame, but for the second frame we're going to do something very interesting. We're going to take the output from the first frame and then encrypt that along with gollywampus here to get yet another key, and now we have a 2 in front of it. We have a counter going, and then we would send that across and use that. Now when that after that one, we're going to take this and concatenate it to gollywampus, and then we're going to have yet a different one. So it's going to keep changing, and it changes every time we have we send a new message, or every time we send change the key. We rely on the output from the last key and chain it together so that the last key helps us to remake the next key. And we're going from RC4, which is a stream cipher, to AES, which is a block cipher. So this is, by the way, this is a symmetric cipher. Symmetry doesn't matter when it comes to RC4 because it's a stream cipher, and so you can't have asymmetric or symmetric. But when you start with block ciphers, then you can. And so it turns out that excuse me, the AES is a block cipher system. It just continues to chain. And by the way, CCMP stands for Counter Mode with Cipher Block Chaining Message Authentication Code Protocol. Counter mode, we've got the counters. Cipher block chaining, this is that chaining system where we keep chaining the output of the last results to the input of the next one. Message authentication code protocol. So that's how it works. We also still maintain personal and enterprise versions, as I described in WPA2, whereas enterprise here uses a separate server for the authentication, and then that way everybody can have their own passwords. Or if we don't have an authentication server, we can simply use the pre-shared key, the gollywampus here, in order to do that, but everybody has to use the same password to get onto it. What else do I want to mention about this? Well, I guess that's pretty much it. So that's WPA2. Now, I'm not going to make a separate video on WPA3. It's very new. We aren't really seeing it on the market yet, even though it was approved in 2018. And it does have some new stuff, which I'm not going to get into because you will not see it on your MTA exam. And to be quite honest, it already has vulnerabilities that we have discovered before it's even out in the market yet. So I'm not sure what's going to happen with that, but you will only see up to WPA2 with maybe just a reference to the fact that WPA3 is out there.